which we get to in question 3. We're going to be asked to factor fully. So what we're going to do is we're going to look at the last number. It's a beautiful last number. You know what's wonderful about 2? There's only going to be 1 and 2 as possibilities. Plus 1 or minus 1, plus 2 or minus 2. So it isn't that many to check. Okay, if you want to write steps out, some people like steps. That's our first step. In this, the 2 is the constant. That's the number all by itself. We want to use the factor property to find one factor. So our choices are plus or minus 1, plus or minus 2, and as far as the setup, I put brackets around this and say, I'm going to let p of x equal this. I like to try the ones first because mental math-wise, that's the easiest. And mental math-wise, positive 1 seems like the easier one to do between positive 1 and negative 1. Now, if I'm a little bit hopeful, for education purposes, I hope it doesn't work. If I was a student, I'd be like, I hope the first one I guess works. So for educational purposes, plugging in 1, do you see this will be 3 minus 4 minus 5 plus 2? Mental math is super easy. And for educational purposes, I'm happy. As a student, I'd be disappointed. I didn't get 0. That means x minus 1 is not a factor. So now I'm going to try minus 1. I can even not a factor. Right? Really show my disappointment to my paper. Draw that sad face. Deep down, the teacher's happy because it didn't work. But as a student, disappointed. Now I'm going to try p of minus 1. You see a negative cubed will be negative, so this will be negative 3. A negative squared will be positive times that negative 4, minus 4. Negative times positive, positive 5, plus 2. I get 0. Super happy, both as a teacher and as a student. I now know that x plus 1 is a factor. Next, we're going to use synthetic division and write the division statement. And some people don't, like after this, you might just go to synthetic division anyways, right? We can find out if something's a factor if the remainder is 0. And you can find the remainder is 0 either with the remainder theorem or with synthetic division. So we could have done synthetic, like sometimes if you're already done step 2, you've already done the synthetic division, all you have to do is write your division statement. But I didn't do synthetic division because I was using ones, so now I'm going to use synthetic division with x plus 1 is the factor. So the minus 1 comes out in front. This is where this unit can play tricks on your mind. Because you know how often we change things from positive 1 to negative 1 to positive 1 to negative 1? Whew. So I plugged in minus 1. which meant that x plus 1 was the factor, which in synthetic division makes it go back to a minus 1. So be careful with the switching, because can you see yourself making a mistake with the positives and the negatives? I'm going to put 3, minus 4, minus 5, and 2. I do not have to write any zeros, and I double check the order is correct. Bring down the 3. Multiply, add, multiply, add, multiply, add, and you should get that remainder of 0. Otherwise, somewhere you screwed up. Because if that remainder isn't 0, it's no longer a factor. So either you did some mental math wrong, or you did some initial math wrong. Something went wrong. But now I can write the division statement. And because I said let P of x equal, I can just write P of x again. If you don't do that P of x, you have to rewrite that whole thing out. It's a little annoying. P of x equals x plus 1 is my divisor. My quotient is 3x squared minus 7x plus 2. And we've written our division statement. How about this for step 3? Step 3 means you're going to have to repeat the process 1 and 2 unless you get a quadratic, which we did. If you get a quadratic, you now can factor completely by just factoring normally. How do I factor 3x squared minus 7x plus 2? Well, my first number is a 3x squared. If it's factorable, the only possibility is 3x and x. My last number is 2. It's going to have to be a 1 and a 2 or a 2 and a 1, but I need my outside and my inside to make 7. Can you see that I have to put my 2 here so my outside is 6, and my 1 here so my inside is 1? And if I want minus 7, my outside would have to be negative 6, my inside negative 1. Double check that by multiplying it out, and sure enough, it works out perfectly. I can put a circle around this because now we have factored fully. If it's a factor fully question and it starts with an x cubed, the first time you get a factor, does it make sense that you'll be down to an x squared? But if you started with an x to the 4, the first time you'd factor, you would get to an x cubed. And that's why it says in step 3, you might have to repeat. Find the next one that works for your x cubed and break it down again. And then you would get to an x squared and you'd factor it completely. With an x to the 4, does it make sense that you could have up to 4 things that factor completely? X plus something, x plus something, x plus something, x plus something. Right? I want to make your life miserable. I'll give you an x to the 73 for it. You just have, that's perfect spring break work. One question, take you all spring break. Right? No, I won't do that. But those are the steps for factoring, and the questions you can do for this one are 5, 11, 9, I don't know why I have these written in the wrong order. Sorry. 5, 9, 10B, and 11.